has to do with taking radicals that have a number in the denominator under the radical. You can't, a number is not completely simplified if there is a square root in the denominator, so you have to have a way to remove that. And the way to remove it is called rationalizing. Okay, so if you have something like this, right, so you have a fraction inside of a radical, you can split the radical and apply it to the numerator and denominator independently. So this is really equivalent to the square root of 3 over the square root of 25. Well, what does the square root of 25 simplify to? 5. And so we didn't have to rationalize this because the square root actually simplified from the denominator. Okay, but what if it was kind of the other way around? What if you had a number like 36 over 5 inside of a radical? Okay, so we'd still split it up, apply the radical to the individual parts, the numerator and denominator independently. The numerator can simplify. What is the square root of 36? But the square root of 5 cannot. So you have to perform this rationalizing step. And the way that you rationalize is you would reduce your base as much as you can. So are there any perfect square factors that you can remove from 5? No. So you simplify that as much as you can. And then what you're going to do is you're going to multiply the top and bottom by the same radical. So in this case, a square root of whatever your base is, 5 over itself. Because here, this is the identity property of multiplication. You can multiply something by or anytime you have some number over itself, it's equivalent to 1, and multiplying by 1 does not change the value of an expression. And so what we can now do is multiply across the top, 6 times root 5. And when we multiply across the bottom, root 5 times root 5 is really root 25. And what is the square root of 25? 5. And so if you follow these steps, it's always just going to simplify to whatever this base that you used was. So what if you had something like this, the square root of 5 over 6? Can you simplify either the numerator or denominator in this case? No. So it winds up with root 5 over root 6. And now you can rationalize. When you rationalize, you again look to reduce your denominator. Are there any perfect squares you can remove from 6? No. So we're going to multiply by the square root of 6 over itself. And across the top, you can combine products inside the same radical. So 5 times 6 is 30. So we can combine those together in one radical. And then root 6 times root 6 just simplifies to 6. Okay, and so again, when you write these, and let me show the format for writing these. This top one, you would write 6 sqrt parentheses 5 and then slash 5. That puts it divided by 5. Same here, sqrt parentheses 30 slash 6 is how you would enter these online.
Why is it that you can't have a square root in the denominator?
That's just one of the, it's kind of like having a fraction with decimals in it. It's not considered simplified or reduced if it has kind of the mixed parts in it. Okay. All right. So what I would like you to do, and again, if you're using your calculator, which I'm guessing a number of you are, I'll talk about that later, but if you know how to use it, that's okay. 36 to 50, I want you to work on those, please. Again, let me go ahead and just talk through the calculator here really quick. And that is, if you're looking to simplify, the square root button on your calculator is right above the multiplication. And so if you want to simplify the square root of 5 over 6, you can simply type that in, the square root of 5 over 6, close off the parentheses, and when you hit enter, it'll do all the simplifying for you. If you take the square root of 36 over 5, same thing, Second, the square root button. 36 divided by 5. Close it off. Again, anytime you're using the square root button, the parentheses will exist. Need to be used. So you get 6 root 5 over 5. Again, confirms what we got by hand.